Why do atoms bond? So sodium reacts with chlorine to form sodium chloride, table salt, right? But why really do they do that? So to answer this, we should look at things or elements that do not react at all, and try to figure out why they do not react. So if you recall, group 0 elements do not react, right? Or group 8 or group 18, right? They do not react. And they're also termed noble gases. So why do they not react? It's because their electronic configuration is very stable. They have a very stable arrangement in their outermost shell, which makes them unreactive. Now, the word unreactive might seem too different from the word stable, but in chemistry they're mostly interchangeable. Or in other words, they mean the same thing. Stable, to be stable is to be unreactive, right? You're not volatile, you're not reactive. Volatile as in the English word, not volatility, right? You're not hot-headed, you really want to react, you're not aggressive, you're very passive, very chill, you do not react. So stable and unreactive mean the same thing. But let's look at why noble gases are stable. With the exception of helium over here, we see that in their outer electron, each of these noble gases will always have 8 electrons in their outermost shell. 8 electrons, outermost shell. Now, outermost shell is important. Okay. They have 8 electrons, and that's what every atom is after. Okay. Aside from, there are a few exceptions like hydrogen and helium that have the maximum capacity of 2 electrons in their outer shell. So hydrogen and helium will strive to attain 2 electrons in their outermost shell. Over here, they're trying their best. Aside from helium and hydrogen, every other atom is trying their best to have 8 electrons in their outer shell. But we've kind of covered this, right? But let's move on, just a good revision. Also, this particular rule is known as the octet rule. You recall that as well, right? So octet, the word octet is derived from 8, octopus and octagon. Octet rule. Okay, so they're all trying to have 8 electrons in their outermost shell.